Left to its own devices, a computer will follow line after line of program code until there are no more left to execute. In reality, however, a computer is not always left to its own devices. Midway through running a process, the computer might be required to divert its attention to something that was not part of the program that it was executing. When this happens, an interrupt has occurred.
An interrupt is a signal generated by either hardware or software which causes the computer to suspend its present activity and switch temporarily to a new process. When this takes place, the computer keeps a record of the instruction that it was executing to allow it to go back to the process it was running before. When an interrupt occurs, an interrupt handler is run. An interrupt handler is a specialized piece of code whose only purpose is to specify what actions the computer should take in the event of an interrupt.
Different types of interrupt exist, which can be divided into two categories: hardware and software. A hardware interrupt is often initiated by a human user. A person clicking a mouse, pressing a button on a keyboard, or inserting a new piece of hardware such as a USB flash drive are examples of interrupts. Other hardware interrupts are not generated directly by a human user. A mechanical failure on a hard disk drive or detection of imminent power loss will also trigger an interrupt.
A software interrupt occurs when something exceptional takes place during program execution. An example of this would be an attempt to divide by zero, or a command to access a file that no longer exists. Exceptional circumstances such as these trigger an event called an exception. Exceptions become errors, which can cause programs to crash if they are not handled.
When an interrupt takes place, the interrupt handler is launched. At that point, the computer saves the state of the process currently being executed to prevent the interrupt causing any processing work to need redoing later. Then, the interrupt handler runs line by line like any other piece of software. It's possible, however, that the interrupt handler itself might be interrupted by a second interrupt, and this is where priorities become important.
Each interrupt is assigned a priority, which is a measure of how important that interrupt is. More important interrupts are assigned a higher priority. If an interrupt is interrupted and the new interrupt has a higher priority, the new interrupt is handled first. The state of the old interrupt is saved, just as the state of the original program was saved, so it can be picked up later. If the new interrupt has a lower priority than the old one is fully handled before the new one can begin.